Okay, today we're going to have a look at topic 8, Introduction to Inequalities. And we'll divide this topic into two parts. In part A, we'll have a look at the basic concept of inequalities and comparing numbers together with linear inequalities. And in part B, we're going to have a look at how to graph inequalities and study optimization problem, specifically the linear optimization problems. Okay, first of all, let's have a look at the basics of inequalities. So, so far we have primarily dealt with expressions that are equal. We write equations to show this equality, right? Such as 2 plus 7 equals 9. And from now on, we deal with expressions in this section which are not equal. So if we know the one expression is greater than the other, we can write a inequality to show this relationship. So we can use greater than or less than to denote this kind of relationship. So this sign here tells us that 2 plus 7 is greater than 5. We could also write this relationship with 5 on the left side. So these two expressions are essentially the same, right? In other words, the inequality 5 is less than 2 plus 7 also tells that 5 is less than the sum of 2 and 7. So both of the inequalities above are called strict inequalities, since one side must be greater than the other. Of course, we can also write non-strict inequalities in which one side is greater than or equal to the other. For example, because 5 minus 3 is greater than or equal to 2, right? We can then write this in mathematical language. 5 minus 3 is greater than or equal to 2. Okay, so let's have a look at a example question which introduces the basic property of inequalities. So in previous sections, we reviewed various ways in which we can manipulate equations. So here we do the same with inequalities. First question asks if Billy is taller than Jimmy, Jimmy is taller than Pat, is Billy taller than Pat? So it might seem obvious to you, right? So because Billy is taller than Jimmy, Billy is taller than everyone who is ever shorter than Jamie, right? Since Pat is one of these people that is shorter than Jamie, then we know that Billy is taller than Pat too. So the first one is true, right? You follow me? Okay, second question. If A is greater than B and B is greater than C, is A greater than C? Assume A, B, and C are real numbers. So this is essentially the same as the first part, right? Because A is larger than B and B is larger than C, we know that A is larger than C, so A must be larger than C. So the second one is also true, right? We can also see this on the number line. Because we know A is larger than B, that means A is to the right side of B, right? So if we label them on the number axis, A must be to the right of number B. Also, since B is greater than C, B must be to the right of C. So C must be somewhere here, right? Because we know A is to the right side of B and B is to the right of C, and we then know A is to the right side of C. That means A must be larger than C, right? And we can also put the inequalities A is greater than B and B is greater than C. We can write this in a single statement, which means A is greater than B, which is greater than C. We can combine them together. And sometimes we call such a combination of inequalities an inequality chain. So this is called an inequality chain. Any questions?
Isn't B less than C?
B is greater than C, it says here.
Oh.
Right?
Still a second problem. Alright. Sorry.
Oh, no problem. Okay. And for the third question, if A is greater than B and B is less, we were talking about question B. Now we're talking about question C. Okay. So in this question, if A is greater than B and B is less than C, do we know which of A and C is larger? Well, actually, we don't know how to relate A and B, right? Because A is somewhere to the right of B and C is to the right of B, but we don't know if A or C is larger, right? For example, in question C, we could let A equals 3, B equals 2, and C equals 4. That means A is larger than B and B is smaller than C, right? But in that case, we know A is smaller than C. On the other hand, if we let A equals 4, B equals 2, and C equals 3, this is also possible, which is A is larger than B, B is smaller than C. But in that case, we know A is larger than C, right? So we cannot determine which one is larger for A or C. So let's put this in a summary. So this tells us that if A is larger than B and B is larger than C, then we must have A is larger than C, right? And similarly, if you have A is greater than or equal to B and B is greater than or equal to C, then we will have A is greater than or equal to C. Did you get it? So this is one of the basic properties you should know, all right? So I'll give you 1 minute to have a look at that. Probably want to write this down on your notebook. All right, then let's have a look at some other questions. Let's consider these 5 questions. First, Bill Gates has more money than Warren Buffett. If they both win a $100 million lottery, will Bill Gates still have more money than Warren Buffett? What if they both give $1 million to the Art of Problem Solving Foundation? Then who will have more money? Okay, let's start from the first one, okay? So if they both win $1 million, both of them have the same increase in the amount of money that they have, right? So the difference between the amount of money each has will stay the same. Specifically, Gates will still have more money than Buffett, right? And for the second question, similarly, if they both donate $100 million to the foundation, then both of them have their wealth changed by the same amount, right? So the difference between the amount of money Gates has and the amount of money Buffett has will stay the same, which means we have the same result. Gates will still have more money than Buffett, right? A very intuitive conclusion here. Did you get it? So let's put it in an abstract way. For the rest of the parts, if we let x is greater than y, a is greater than b, and c is greater than 0. So it seems that we will have this relationship, right? X plus c will still be larger than y plus c. So can you explain why? So I'll give you 1 minute to think about this, all right? Okay, let's have a look at what possible explanation for this. So if we have x is larger than y, so if we draw them on the number axis, x must be to the right side of y, right? So suppose x is here, y is here. Then when we add c to each of x or y, we simply move z steps to the right of each on the number line, right? In other words, x plus c and y plus c are c to the right of x and y. So suppose this is x plus c here. Then we simply move y to the right side for a distance of c. So this is y plus c, right? So if you have originally x is greater than y, then move c steps to the right of each of the number line for x and y. Of course, we'll still have x plus c is greater than y plus c, right? So that means if you have x is greater than y, and c is larger than 0, you will always have x plus c is greater than y plus c, right? So this is similar for question C. If you have x is greater than y, then x minus c is greater than y minus c. Because, again, we can illustrate this on a number axis. So originally we have x is larger than y, so this is our x, and y to the left of x, right? Subtraction is moving left on the number lines, just as with addition. Moving the same distance to the left of x, so suppose this is x minus c, then this must be y minus c, right? Therefore, if you have originally x is larger than y, then that indicates x minus c must be larger than y minus c, because x minus c is still to the right side of y minus c. You see that? You have any questions? Okay, if not, let's have a look at question D. So can you explain why x plus a is greater than y plus b? So here, Remember the relationship between x, y, a, and b. We have x is larger than y and a is larger than b, right? So that means if you have x is larger than y, a is larger than b, then that implies x plus a must be larger than y plus b. Again, it seems obvious, but can you explain why? Okay, we can do this on a number line. So originally we have x is greater than y and a is greater than b, right? So in order to facilitate our discussion, let's suppose a is greater than b and both a and b are positive numbers. Since x is greater than y, we know x is to the right of y, right? Adding a to x moves more to the right than adding b to y. So suppose this is y plus b. Then x plus a must be somewhere here. The distance between x and x plus a is greater than the distance between y and y plus b, right? Since x started to the right of y, the number x plus a must also be to the right of y plus b, right? Therefore, we have if x is greater than y and a is greater than b, which is greater than 0, it will always have x plus a is greater than y plus b. Of course, you can use the same method to prove the other case where both a and b are negative numbers, or one of them is 0, right? Or one of them is positive, the other one is negative. The same result will still hold, right? We could also have reasons through this without using the number line. So suppose you don't use the number line, you will still get the same result. We know that x is greater than y, right? Therefore, we will have x plus a is greater than y plus a. This is what we have already learned in previous part, right? And we also know that a is greater than b. And adding y to both sides of this inequality gives us y plus a is greater than y plus b, right? So if we consider this inequality and the second inequality, we can combine them together in an inequality chain, which means x plus a must be greater than y plus a, which must be greater than y plus b, right? Therefore, we have proved x plus a must be greater than y plus b. Did you get it? And if you don't have any questions, let's have a look at the last question. E. Is it always true that if x is greater than y and a is greater than b, then x plus b is greater than y plus a? Is it true or not? Well, actually, this is not always true, right? For example, note that 9 is greater than 8 and 5 is greater than 2. But 9 plus this number 2 is not greater than, which means less than 8 plus 5, right? So if we can find a counterexample, that means this statement is not always true, but sometimes it's true, right? For example, if you still have 9 is greater than 8, and this time, let's suppose okay, 9 is, let's use 19 then. 19 is greater than 8, and 5 is greater than 2, right? And then we have 19 plus 2 must be greater than 8 plus 5, right? That means sometimes this statement is true, sometimes it's not, right? Therefore, it's not always true. Did you get it? Okay, so to summarize, this is the second property of inequality we learned in today's lesson. If x is greater than y, then we have x plus c must be greater than y plus c for any real number c. If we also have a is greater than b, then we will have x plus a is greater than y plus b. This is also true for the non-strict inequalities, which states that if x is greater than or equal to y, and and then we will have x plus c must be greater than or equal to y plus c for any real number c. If we also have a is greater than or equal to b, then we'll have x plus a is greater than or equal to y plus b. You get it? So please have a look at this property. And any questions, just let me know, okay? All right, have we finished? So if you don't have any questions, we have already tackled addition and subtraction, right? And now let's try multiplication and division. So let's consider this question here. If x is greater than y and a is greater than 0, is it true that xa is greater than ya? So if you think it's true, can you prove this is actually true? Or if you think it's not always true or it's false, can you give it a counter example? So I'll give you 2 minutes to consider this problem to see if you can explain this, okay? All right, so if you have finished, let's have a look at the solution together. So here we need to prove something about products, right? So only thing we know about products and inequalities is that the product of two positive numbers is still a positive number, right? So let's see if we can use that to explain. So first of all, we already have a positive number here, a. And we can start from the statement x is greater than y. So we know that because x is greater than y, we can simply subtract y to both sides, right? That means x minus y is greater than 0, right? So because x is greater than y, if we subtract y or add negative y to both sides of the inequality, then we'll get x minus y is greater than 0. You can also consider this as if you move any term to the other side, then you should put a negative symbol in front of that, right? And we also know that a is a positive number, right? Then we have the product of two positive number is still greater than 0. So we have x minus y multiplied by a is greater than 0, right? And this tells us that we can distribute a into the parentheses. This will give us xa minus ya is greater than 0, right? Then we can move negative ya to the other side of the inequality. Then remember, we need to change its sign from negative to positive. That means xa is greater than ya, right? Therefore, if we have x is greater than y and a is greater than 0, then we must have x times a is greater than y times a. And let's put this in a summary. So this tells us that if we have x is greater than y and you have a positive number a, then if you multiply the original inequality using a positive number, this does not change the inequality sign. Does not change the direction of the inequality sign, right? And of course, this is also true for the non-strict inequality. If we have x is greater than or equal to y, and a is greater than 0, then we can simply multiply the original inequality using the positive number a, and this does not change the direction of the inequality sign. And this is the third property of inequality we have learned so far, right? Okay, if you don't have any questions, let's consider another problem. Suppose x, y, a, and b are all positive, and that x is greater than y and a is greater than b. So basically we have x is greater than y, which is greater than 0, right? And a is greater than b, which is greater than 0. So is it true that x multiplied by a is greater than y multiplied by b? And is it true that x over a is greater than y over b? And what will happen if our variables are allowed to be negative? Again, I'll give you 2 minutes to think about this question, and we'll have a look at solution together, okay? Okay, have you finished? Well, intuitively, it seems clear that we can know xa is greater than yb, right? Since we just multiply two big numbers and two small numbers. Well, actually, we can use the result of previous problem to see. So because we have x is greater than y, which is greater than 0, and a is greater than b, which is greater than 0, then first of all, we have x times a must be greater than y times a, right? Because we simply multiply both sides of the original inequality here using a positive number a. And if we consider this inequality, we can multiply that inequality using the number y, which means we can also have ya must be greater than yb, right? Then we can combine these two inequalities together, and therefore we have xa must be greater than ya, which is greater than yb, right? Therefore, we can actually prove xa must be greater than yb. Did you get it? So the first statement is always true. But the second statement is not necessarily true, right? Because a larger number x is divided by a larger number a does not necessarily mean the left side is larger than the ratio of the right side. Did you get it? For example, let's consider if x equals 4, y equals 1, a equals 7, and b equals 1. Then in that case, left side is simply 4 over 7. And right side is 1, right? We know that 4 over 7 is less than 1, right? But if you enlarge x a little bit, so for example, let x equals 40, and y is still 1, so that means x is still larger than y, right? And let's keep a unchanged and b unchanged. In that case, left side is simply 40 over 7. The right side is still 1. Then in that case, we know the left side is greater than 1, right? So the second statement is not necessarily true. Did you get it? So if we put this all together, we have the following properties. If x is greater than y, and both of them are positive numbers, and a is greater than b, and both of them are positive numbers, then we have x times a must be greater than y times b. And this is also true for the non-strict inequalities. For example, if we have x is greater than or equal to y, which is greater than 0, and a is greater than or equal to b, and both of them are greater than 0, then we must have x times a is greater than or equal to y times b. Did you get it? This is the fourth property we have learned so far in this class, right? So give yourself some time to understand this. Any questions, just let me know, okay? All right, so if you don't have any questions, we have considered cases to multiply a positive number to the original inequality. We don't change the direction of the original inequality, right? So how about if we multiply both sides of the inequality using a negative number? For example, let's consider this question here. If we have x is greater than y and a is a negative number, which means a is less than 0, then what can we say about the quantities xa and ya? So I'll give you three options. A, xa is smaller than ya. Option B, xa equals ya. Option C, xa must be larger than ya. Which one is correct? Give me your answer in the chat box, okay? Okay, give me your answer in the chat box. Thank you, Ben. All right, actually A is correct, right? So can you prove that? Well, we can actually prove it. The product of a negative number and a positive number is negative, right? So originally we have x is greater than y and a is less than 0, right? From x is greater than y, we have x minus y must be greater than 0, right? And because a is less than 0, we have x minus y times a. X minus y is positive, a is negative. The positive number multiplied by a negative number must be a negative number. That's less than 0, right? And therefore we have xa minus ya must be less than 0, and eventually we must have xa less than ya. We can prove xa is less than ya, right? So that means if we multiply a negative number to both sides of the original inequality, we need to change the direction of the inequality sign. Did you get it? So if we multiply or divide an inequality by a negative number, we must reverse the sign. For example, if x is larger than y and a is less than 0, then we must have x times a is less than y times a. Did you get it? And this is a fifth property we have learned in today's lesson. Alright, if you don't have any question, let's consider another problem. So in question A, for any positive integer a which is larger, 7 raised to the power of a or 5 raised to the power of a, which one is larger? Okay, actually 7 to the power of a is larger, right? We saw earlier that if x is greater than y, which is greater than 0, and a is greater than b, which is greater than 0, we must have a x times a is larger than b times y, right? So here we simply have 7 is greater than 5, which is greater than 0, and 7 is greater than 5 and greater than 0. And we then have 7 to the power of 2 is greater than 5 to the power of 2, right? We can continue this 8 times to find 7 to the power of a is greater than 5 to the power of a, because it says a is simply a positive integer, right? So we can use this logic when raising any two positive numbers to an integer power. So our question B, if a is positive integer besides 1, which is larger? A's root of 7 or a's root of 5? Which one is larger? Well, this looks like a lot like the last part, right? So we can try to use what we know about powers to solve this problem. Whatever a is, we know that we have the a's power of 7, then raised to the power of a will give us 7, right? And the a's power of 5 raised to the power of a will still give us 5, right? So from question A, we know that if the a's power of 7 is less than a's power of 5, then we can raise both sides to the a power to get 7 is less than 5, right? But this is not true. Therefore, it's impossible that a's power of 7 is less than a's power of 5. The two quantities are also clearly not equal. So we know that a's power of 7 should be greater than a's power of 5, right? Did you get it? So how about the third question? Is it always true if x is greater than or equal to y and a is positive, then x to the power of a is greater than or equal to y to the power of a? What do you think? Yes or no? Is it always true or not necessarily true? I'll give you a hint. You need to consider cases where there are negative numbers. It does not say x or y are not necessarily positive numbers, right? For example, we could let x equals 2, y equals 1, and let a be positive number. For example, a equals 2. In that case, we will have x to the power of a is 4, y to the power of a is 1. Of course, we have x to the power of a is greater than or equal to y to the power of a, right? But we could also let y be a negative number. In that case, for example, we could let x equals 2, y equals negative 3, right? Still, we let a equals 2. In that case, x to the power of a is 2 to the power of 2, which is 4. And y to the power of a is negative 3 to the power of 2, which is 9, right? In that case, we know x to the power of a is less than or equal to y to the power of a. So it's not always true that if we have x is greater than or equal to y, a is a positive number, then x to the power of a is greater than or equal to y to the power of a. You need to consider special cases where there are negative numbers, right? Be careful with this. So if we put this all together, then we'll have the following three properties for inequalities. First, if we have x is greater than y, which is greater than 0, that means both x and y are greater than 0, right? And a is positive integer, then we will have x to the power of a is always greater than y to the power of a. And this is also true for the cases where x is greater than or equal to y, and still both of them has to be positive numbers. Secondly, if x is greater than y and both of them are positive numbers and a is positive integer, then we have the eighth root of x must be greater than the eighth root of y. Similarly, if x is greater than or equal to y and both of them are positive numbers and a is positive integer, then we'll have the eighth root of x must be greater than or equal to the eighth root of y. Did you get it? And we have also the third property here. If x is larger than y, which is larger than 0, and then for any positive real number a, we always have x to the power of a, which is greater than y to the power of a. So similarly, we have if x is larger than or equal to y, which is greater than 0, then for any positive real number a, we always have x to the power of a is greater than y to the power of a. So I'll leave this to you as your homework. So think about how we can prove this statements here, okay? The difference between the third property and the previous two is that a actually can be any positive real number, not necessarily a positive integer. All right, have you finished? Write this down, all right? And there's another property. If x is real, then we must have x squared is greater than or equal to 0, which means if x is real, we always have x squared is non-negative. So can you prove this is true? Clearly, if x is positive, then its square is positive, right? Since the product of two positive numbers is positive. If x is 0, its square equals 0. So statement is obviously true if x is greater than or equal to 0. So what if x is a negative number? If x is negative, then x squared is a product of two negative numbers, right? Because the product of two negative numbers is also positive, so x squared is positive when x is negative. So these are the only cases, since x must be positive, negative, or 0. We have already covered all the cases here. And then x squared is non-negative in all three cases, right? Therefore, we know if x is real, we always have x squared is greater than or equal to 0. Do you get it? So you can treat this as another property of the inequality instead. Okay, so far we have covered addition, subtraction, multiplication, and division, right? We have also covered the cases of exponents. Now let's consider the reciprocals. So let's consider this question here. Suppose x and y are positive numbers such that x is larger than y. Which of the following is larger? The reciprocal of x or the reciprocal of y? What if y is negative and x is positive? If you have made your conclusion, can you prove this? Alright, let's have a look at how we can explain this. So originally we have x is greater than y, and both of them are positive numbers, right? So we could state that because x is greater than y, which is greater than 0, this ensures x and y are both positive numbers, right? Then we know that the product with two numbers must also be greater than 0, right? Then if we simply divide both sides of this inequality using the positive number x times y, we have x over xy must be greater than y over xy, right? Because if you divide both sides of an inequality using a positive number, we do not change the direction of the inequality sign. And this means, okay, cancel x here, y over y, cancel y here. 1 over y must be greater than 1 over x for the cases where x is greater than y, which is greater than 0, right? For the second question, what if y is negative and x is positive? So because we know x is greater than y, x is positive, y is negative, right? In that case, the product of x times y must be less than 0, which is a positive number. And if you divide both sides of this inequality using a negative number, x over y, you must change the direction of that inequality, which means x over xy must be less than y over xy, right? This is according to what we have learned previously. Therefore, again, if you cancel x here, cancel a y here, that means y 1 over y must be less than or smaller than 1 over x in the second case. Did you get it? Okay, so if we put this together, this is another property of the inequalities. If x is larger than y and x and y have the same sign, both positive or negative, then we must have 1 over x is less than 1 over y. So previously we have showed cases where both of them are positive, right? So after this class, you can prove the cases where both of them are negative. This is also true. And secondly, if x is greater than or equal to y and x and y have the same sign, again, both positive or both negative, then we also have 1 over x is less than or equal to 1 over y. So have a look at the property here. Any questions, just let me know, okay? Alright, if you don't have any questions, let's have a look at the second part of today's lesson, which we compare two numbers. These are the typical questions in which we compare two numbers. Which number is larger? Let's use this as the example, okay? To illustrate the common method we can use compare two numbers. Which number is larger here? So the first one or the second one? So neither of them is a simple integers, right? Suppose you don't have a calculator. Can you compare them manually? Okay, I'll lead you through this, alright? So here, we'd like to determine which of greater than or less than we should put in place of here, right? So first of all, we simply use a question mark to comparison numbers here. We don't know which one should we use here, right? The square roots are very annoying, so we're going to remove that. And we know that squaring both sides won't change the direction of the inequality sign, right? So we can square both sides. This means 3 times 6 squared 2. Still, we could put a question mark here. This does not change the direction of the inequality sign. Still more radicals to get rid of, so we square again. Again, this does not change the direction of the inequality sign, right? So the left side simply becomes 3 squared times 6 square root 2. And this becomes 6 squared times 2 square root 3, right? And we do that one more time. Again, this does not change the direction of the inequality sign. So we have 3 to the power 4 times 6 to the power 2 times 2. The right side we have 6 to the power 4 times 2 to the power 2 times 3, right? We could multiply both sides out, but it's even easier if we can cancel some common terms first. So if you use the number on the left side over the number on the right side, then you will cancel a 3 here. You have 3 to the power 3. Then cancel a 2 here. You got a 2 here. And then we have 6 to the power of 2, right? And this means we have 27 over 70 something, right? You don't even have to calculate this number here. Well, 72, which is less than 1, right? Which means 3 to the power 4 times 6 to the power 2 times 2 must be less than this number here, right? Which means we should put a smaller than sign here, which means all of the signs are smaller than, because for each step we don't change the direction of the inequality, right? So originally the first number is smaller than the second number. Did you get it? Do you have any questions? Okay, if you don't, let's consider another question. Can you order the following numbers from least to greatest? Okay, so here we can use some trick again. We can take the 25th root of each number, right? So because the exponents are too large, we don't like that. So we simply take the 25th root of 4 numbers. The first number becomes 2 to the power of 12. Second number becomes 3 to the power of 8. Third number becomes 4 to the power of 5. And the last number becomes 5 to the power of 4. Again, if you simply put the 25th root of each number, this does not change the inequality sign between each two numbers, right? And these numbers are actually very easy to compute. The first number is simply 4096. Second number is 6561. The third number is 1024. The last number is 625. And actually you can sort this number in ascending order. 625 is less than 1024, less than 4096, which is less than 6561, right? then we know that 5 to the power of 4, well, actually 5 to the power of 100 must be less than this number here, which corresponds to originally 4 to the power of 125, which is less than this number here. And that number corresponds to 2 to the power of 300, which is less than the number here, which corresponds to, if you follow this route, you will get the original number, which is 3 to the power of 200, right? You get it? Any questions? Okay, if no questions, let's consider another question. So suppose we have two numbers, uppercase A and uppercase B. Which one is larger? Without using a calculator. I'll give you 1 minute to think about that, and we'll have a look at the solution together, okay? Well, so here we can use a trick to compare A and B. So if you can't directly find A and B easily without using a calculator, usually we can take their reciprocals, right? So the reciprocal of A gives us this number here. And this is very easy to calculate, right? Because we can simply separate the numerator as the denominator plus 1, right? So that gives us 1 plus 1 over this very large number here. And do the same thing for B. Take the reciprocal of B. This will give us 1 plus 1 over this very large number here. And apparently this number is smaller than this number, right? Because when the denominator is a positive number and is larger than this one, then we have this number is actually smaller. Therefore, we have 1 over A is actually smaller than 1 over B, right? And we know we can multiply both sides using the product of A and B, which is a positive number. Then we have B must be greater than A, right? Sorry. B smaller than A. We don't change the direction of the inequality sign, right? So A is larger than B. And this tells us that some pairs of numbers can be mostly easily compared by considering the reciprocals of the numbers rather than the irrational numbers. Did you get it? Okay, so if you don't have any questions, next let's have a look at how we can solve simple linear inequalities. Usually you can make use of the number axis to help you find the solution of inequalities. And usually we'll use this notation here. So suppose we have an inequality x is larger than 7, and you can illustrate this inequality in a number axis, and usually we'll find the point 7 here. X is larger than 7 means x cannot be 7, right? But to the right of the number 7. So all these areas are the possible values of x. That corresponds to this inequality, right? You get it? And for another example, if you want to denote x is larger than or equal to 7, then we'll use a solid dot here, which means x could also equal 7. Okay? Be careful with the difference. If you use a circle, that means x is strictly greater than 7, and usually we'll use a dot here, solid dot, to indicate x could be larger than or equal to 7. Alright? And sometimes we have a system of two inequalities. For example, first one is x is larger than 7. Second one is x is less than or equal to 9. Then the diagram should look like this. This is 7. X is larger than 7 means to the right of 7, right? Then 9 is to the right of 7, so 9 is probably here. X is less than or equal to 9 means to the left of that number here. And then this symbol here means we must find the intervals that can satisfy both of the inequalities. So this is an overlapped area. This area will satisfy both of the inequalities here. Did you get it? This indicates the interval of x that can satisfy both of the inequalities, which satisfies the entire system. Okay, now let's consider some example questions. So first, can you find OX such that 3x minus 7 is greater than or equal to 8 minus 2x? And actually, this is very simple linear inequality because highest order of x is just 1, right? So I'll lead you through this. First of all, you could add 2x to both sides, or you could also consider to move negative 2x to the left side. That means we have 3x plus 2x, then move negative 7 to the right side. Remember, when you move any terms to the other side of the inequality, you need to change the sign. So positive becomes negative, negative becomes positive, right? So that means it's greater than or equal to 8. Negative 7 moved to the other side becomes positive 7. And this means 5x is larger than or equal to 15. So we have x is greater than or equal to 3. This is our final solution. Did you get it? And there is another notation to denote a solution like this. So solution number 2 looks like this. X is greater than or equal to 3 means x belongs to a interval from 3 inclusive to positive infinity. You get it? Or if you want to denote strictly greater than, For example, if you have x is greater than 3, that means x belongs to an interval from 3 to positive infinity. Be careful with the square parentheses here and the round parentheses. They are actually the same. You can choose either one to use, all right? Okay, any questions? Okay, if not, let's consider another practice. Can you solve each of the following inequalities? Again, these are very simple inequalities, right? I'll give you 1 minute to think about, and then we'll have a look at the solution together. Okay, have we finished? The first one, if you want to solve the inequality, the method should be similar to the one as we we use in solving equations, right? So we simply separate the unknown variable x and the constant number. So that means 2x is greater than or equal to, move negative 9 to the other side, becomes positive 9, right? So 2x is greater than or equal to 16, which means x must be greater than or equal to 8. All right, you could use x is greater than or equal to 8 like this, or you could also say x belongs to the interval from 8 inclusive to positive infinity. For the second question, again, separate the unknown variable t and the constants. So we can move negative 3t to the other side because we don't, personally, I don't like negative numbers as a coefficient. So we could simply move negative 3t to the right side. That becomes 8t, right? Larger than 4 plus 7 minus 19. So that means 8t is greater than negative 8, right? And then we have t must be greater than negative 1. So this is our final solution. Or you could also say t belongs to the interval from negative 1 to positive infinity, exclusive, or open interval. You get it? Any questions? Okay, if not, let's consider another one. This time we have a inequality chain like this. 2 plus x is greater than 5 minus 3x, which is larger than 8. Again, I'll give you 1 minute to consider this question first, and then we'll have a look at the solution together, okay? Alright, have you finished? So usually if you have an equality chain like this, we could separate the two inequalities. So basically you need to find the x such that it will satisfy the first one, which is 2 plus x is greater than 5 minus 3x. Secondly, it must satisfy the second inequality, 5 minus 3x larger than 8, right? Then the first inequality gives us 4x must be greater than 3. Second one, well, of course you could consider these inequalities separately. So from the first inequality we have 4x is greater than 3, which means x must be greater than 3 over 4, right? From the second inequality we have 3x must be less than negative 3, which means x must be less than negative 1, right? Do you get it? So that means you need to find the x such that x is larger than 4 over 3 and less than negative 1. Of course here, usually we'll use a number line to help us to find the corresponding solution. So we know negative 1 is here and 3 over 4 is here, right? The first solution tells us that x must be to the right side of 3 over 4. Second solution tells us that x must be to the left side of negative 1. Apparently there is no overlapped area, right? That means you cannot find any solution that can satisfy both of the inequalities. Therefore, we know there is no solution. Or you could simply state that x belongs to empty set. Did you get it? Any questions? Okay, if no questions, let's consider another one. For what values of x is an inequality, is a quantity 2 times square root of x minus 3 is between 7 and 10 plus 1 half. So basically you need to find a solution of x such that this number is between 7 and 10 plus 1 over 2, right? Again, you could separate them to two inequalities. So that's 21 over 2, right? Okay, from the first inequality, we have 2 square root x must be greater than 7 plus 3, which is 10. That means square root of x must be greater than 5, right? And apparently that x must be larger than 25. Because when x is 25, we have square root of 25 equals 5. To have a square root of x is larger than 5, we must have x must be greater than 25. From the second inequality, we have 2 square root x must be less than 27 over 2, which means the square root of x must be greater than 27 over 4. Again, take the square root of that number. Square both sides. This will give us x is greater than 7 to 9 over 16, right? Because when x equals this number, we have square root of x equals 27 over 4. and we know that x must be larger than this number to ensure square root of x is larger than 27/4. So the overlapped area is the solution, and we use the number axis to help us to find that number. Apparently the second number is larger than 25, so if 25 is here, and then that's 729/6, right? First solution states that x must be to the right side of 25. Second solution states that, oh sorry, I made a mistake here. There's a typo. This should be smaller than, not larger than. Sorry about that. And second statement is that x must be less than the second number here. And apparently the interval we are looking for is here. This interval will satisfy both of the inequalities. Therefore, the solution is x must be greater than 25 and less than 729/16, right? Did you get it? Okay, so if you don't have any questions, because we are running out of time, I'll leave the last question for you to solve after this class, okay? So you can consider this as a homework. So please take a picture of this and also consider this as your homework. And I'll give you a separate sheets of questions to solve after this lesson, all right? Okay, so if you don't have any questions, class is over and I'll see you next time. Bye.